Hello everyone and welcome to this lecture on tuples. And in Python, tuples are very similar to list. However, they have a key differences, and that is they have immutability and they are immutable, meaning they cannot be changed, and they and that comes from the term mutation, and they cannot be mutated or changed. Now basically means once an element is assigned to a index position inside a tuple, you cannot grab that element and then reassign it to something else. Like you could have a list, and the way to construct tuple is very similar to list, except instead of using square brackets, now use parentheses. Let's explore tuples a little bit more on Jupyter. So let's get started. You will have a quite an intuition as far as how the tuples use based on you have learned about the list. So we're going to create a two block called T. So we'll say T is equal to the, and then is parenthesis. So we'll write 1 comma 3 2 comma 3, and then we'll create the list. Which is going to be very similar. Then it's a list that you can always confirm this using a built-in type function. So if I say type it like type T, as you can see, it's a tuple. Then so using the built-in type function, so if I say, as you can see, I wrote the T, it returns back to its tuple function. So if I ask the my list, so it returns back that it's a list. So we can check the length of a tuple just like you could have a list. Then let's so C is 3 because 3 element in that list. So 1 2 3 in just like the 3 list. It is also a fine to mix object types, so we can have a string inside of a tuple along with the number, that has no problem there. And also just like a list, you can use slicing and indexing. So let's say I want to grab that string, so I could just say give me what's an index 0, and there I can comma 2 then also do a negative 1. So I have 2 as a return, and then so take a look at the T. It's right here. So it's right here. So let's get to really what makes a tuple different, and that's the immutability. And I really cannot stress enough that this is what makes a tuple a different than list. So let's check out a tuple right now and also check out that list created. So let's assign the first element of my list to be the string. So right now my list has no problem with that. So I will assign the first element to be the new. T is equal to a comma b. Then use the t dot count. So tuple, I created the tuple list and also check out the list. So let's assign the first element to my list, and basically, and that came out t dot count a came out as a 2 output. So let's type t dot index, which will be 0. So right away you will notice that there is a list method available to tuple. Then let's complete that. T dot index b it came out 2. Then T is A and B, okay. Then my list, which is 1 2 3, 1 comma 2 comma 3. and then my list 0 is equal to new then my list again, which will add new 2 and 3. So if I try to do the same thing with the tuple as I did there, so it is going to say the type error. So let me do that. Okay. So tuple object does not support item assignment. So that's basically what it makes a tuple different than a list. Now I'm sure you're wondering, well, why would I even bother using tuples when they have fewer available methods and they don't have the flexibility of a list. So, and to be honest, so you are beginning to program, you not going to be using tuples that often. It's only as you become more comfortable with Python and become a more advanced programmer, then you will begin to see what benefits of tuple and what you are going to be using tuples for mainly when you are passing around the object in your program. And you need to make sure that they don't accidentally get changed, and when the tuple really becomes a great solution, so tuple becomes a great solution, so it provides a very convenient source of what's known as data integrity. The fact that we cannot do reassignment like this by accident, we will get an error instead, is going to be really useful when you want to make sure that elements don't get flipped or reassigned later on a large piece of code. So kind of keep this in your toolkit, and later on I'm sure we will be pulling out this tuples again, so we can use it and really let it shine. For now, just remember that it has immutability and it looks really similar to a list, except we use parentheses instead of square brackets. Okay, so that's it for the tuples. So we're going to show you how to use the next. So now we'll be talking about the list data structure and Python. So we are going to learn about how that list can be thought as probably one of the most general version of sequences in Python. So let's go ahead and get started. Here I have opened a Jupyter notebook, and we are going to learn about creating the indexing and slicing list and some of the basic list of method that the next list is, and we will get a quick introduction to these comprehensions. So this is just a quick overview of everything in this Jupyter notebook. So let's go ahead and write our code. So let's go ahead and assign a list to a variable like my underscore list 1, 2, 3. So I'm going to create a variable name called my underscore list, and I'm going to create a list. So lists are constructed with a square brackets, and they have a comma separating each element in that list. So for instance, if I wanted to make a list of a number 1 comma like my underscore list is equal to string comma 23 comma 1 comma 2 So if I wanted to make a list of the number 1 comma 2 comma 3, so right now in this format my list is everything in between these two buckets, and it allows me to keep track of the sequences of element 1, 2 and 3, and they are all separated by comma shift. And then we created a list of integers. So if I say my underscore list, and I can remember that I have my list output as 1 2 3. So I can create my list, and I will set to equal to a new list, and this list going to contain a string and integer 23 and even like a floating point number, so 1 comma 2, and put another string in there for good measures. So there we go. So if I call my list again, len my list, then the okay. So for list I can say len on of my list, so there I get the list length is 4, and that's because there are 4 elements and there's a string 23 and 1.2 and that O string. So let's go ahead and jump into indexing and slicing into. So indexing and slicing is gonna work like let me write the code. One, 2, 3, 4 and 5. Then I'll create another list, will be called my list. Then it will take my list 0.
So once you put a string and then 4 1 2 3 and 4 5, remember each of the element is separated by a comma. So since this is a sequence, I can index and grab stuff in these sequences. So if I say my list, that variable name with brackets and then 0, then I will get like this. Wait, my list 0, and now my list, my underscore list 1, one, two, three. Okay, then my underscore list so if I say my list variable name and bracket and then 0, that's going to grab the element at index 0, and in that case it's just the first one. So just like the string and notation and the same soup, let's say I want to put my list and I want to grab index 1. So in this line I grab the index 1 and passed it, and the same color notation. So my list grab everything from this element and return the output 2 3 and 4 5. So let's say I wanted to grab everything up to index 3 in this line. So you can say my list and we will say everything up to the element 3. So colon 3 and the return 1 2 3. So we can use the plus symbol to consent. So let me write that. Hello world. List just like we did for strings. So if you remember from the string lecture, I could say the plus space. So let's say word and word concrete it to a single string like hello world that I typed it right now. So I can actually do the same with list. So I can say my list and that's just that one. So then if I type that my list, then it will give the output like 1 2 3 and 4 5 there. So there it can be another list. So I will create a new list and to that list like my underscore list is equal to my underscore list, or like, okay, not this one. If I add like my list plus new item, then it will first it will give the output like 1 2 3 4 5 and new item. Then again if I write my list is equal to my list plus permanent add, then it will go to the next line, and if I put this in my list, then it will show the output as 1 2 3 4 5 and permanent add. So it added all the strings. So it added the list consisting of a single item, which is just a string. So there's just noted by those square brackets, and there we go. And if you notice, when you continue, it basically kind of just depended on the last item on that list. So if I write my underscore list into 2, then it gave the output like 1 2 3 4 5 permanent list, 1 2 3 4 5 and permanent add. So if I just if I put a string like L is equal to 1 2 3 1 comma 2 comma 3, then it will give the, then L, it will show the output as 1 2 3. Then if I use the append one like L dot append and append dot me, and if I use the L, then it will all show the 1 2 3 and append me. So now if I use pop function like L dot pop, then it will just show the append me as the output. Then if I use x is equal to L dot pop, then give the x, then it will show output as a 1. Then if I also get 2 and 3, but if I try to use the list as 99 or first L1, as you can see it gives a type error because the list object is not callable or also not. So if I use list as 99, it will also show the same error message. But if I create a new list like new underscore list, A B A, So if I create this new list and if I want to show the output, so it will, as you see, it will get the output as AEXBC. So now use the string like new list reverse string. Now it also reverse that, and if we short that string by typing new list dot short, then new list, as you can see it sorted out the new list as it was previously random, and now you can see ABCEX, and previously it was AEXBC, so it just sorted out, and from the random item it reverses and sort. So if I now use list 1 at 1 to 3, 1 comma 2 comma 3, now list 2 at 4 5 6, and list 3 as 7 8 9. And make it as a matrix, like matrix, call it as L1 comma L underscore 2 comma L underscore 3. Then if I write the matrix, and if I, as you can see, matrix out the list that I created previously. So it, now if I want to matrix that like matrix 2 0, so the output came out as 7. Now if I write a new string as first column row 0 for row in matrix, then we make that as a first column, then it came out as 147, as you can see 147 as the first column. So that's how this is came out as a jewel list. So that's the most basic about the Jupyter list.
So now in Python we will talk about the dictionaries. So in Python, dictionaries are indicated by 2 curly brackets. So in order to create a dictionary in Python, all we need to do is to create those 2 brackets and include some value in there, and created the Python, and our dictionary is created. So tricky part is inside those 2 curly braces we need to specify our key value pairs, which are separated by a colon. So let me try that. My dictionary is equal to colon 1:100 comma 3:100 comma 4:400. So as in this code you see that we have created a dictionary and we have sorted it in a variable name my dictionary. So here we can see that there are two curly brackets having key value pairs separated by the comma. So Python got us cover in Python there is a special function called type. So let me use that type my dictionaries, then output will be dictionary. So from this result of the type function it is now confirmed that the variables that we are dealing with is indeed a dictionary one. So Python has an internal coding system where each data type is represented with a shortcut. So here for directory it is dict, accessing elements from a directory. So if you want to access the elements you have to type like my dictionaries two. So as we see here in this code we have access the value 200 from our dictionary based on the key2 students value 2 is mapping to. So now adding a new element to the dictionary. So we will type my dictionary so adding a new element. So if I type my dictionary 5 is equal to 500. So as from this code the syntax for adding a new element to a dictionary is pretty simple. Let's see a brief explanation for the same here. Since we are going to add a new key or dictionary which is 5 in this case, so since we have now added a new key value pair in our dictionary, so let's check that out. So if we type my dictionary, so it will, so from the above output it is evident that our new key value is added to the dictionary. So updating value associated with a dictionary. So we have a dictionary now having a 5 key value pairs respectively. Let's say we decided to update the value of a particular key in the dictionary. So let's update the value 500 with associate to 1000. Now my dictionary 5 with 1000, and if I check that, as you can see the value associated with the key 5 has been successfully updated to 1000. So accessing all the keys from the directory. So if I so as you can see here, the keys method of directory object has returned each and every key is present in our dictionary. So as one important thing need to be remembered, seeing keys is basically a method. It will always be associated with the dictionary object. So if we don't have a dictionary object, we cannot use this method as method dependent on their corresponding object. So accessing all the values in a dictionary. So if we want to access the values, then I want to type my dictionary dot values. As you can see, all the values are shown here: 100, 300, 400, and the last updated one 1000. All return to the value which are present in our dictionary object. And accessing all the items in a dictionary. So if I want to access all the item, I want to type my dictionary dot items, items. Okay, I type it wrong. Okay. So as we can see here, the items method has returned both the keys and the values which are present in our dictionary object. So if we want to getting the list of all method for the dictionary object, we need to use directory method like dir my dict dictionary. Okay. As you can see here, the directory function has listed all the method which can be used with our dictionary data type. So well, that's it. That is everything you need to know about the dictionary data types in Python.